These are the 6.3 notes for Algebra 2. We're going to talk about solving exponential functions today. So the first thing we're going to do is do this exponent practice, and we're just going to solve for the question mark. So 3 to the 4th power equals question mark. What you're going to do is either in your calculator or in your head, multiply 3 out 4 times. So 3 to the 4th means 3 times 3 times 3 times 3. That'll get you 81. You can use your exponent button on the calculator if you wish, or just type in the 3 4 times. The rest of these are just going to be kind of guessing and checking to make sure you have the correct answer. So 2 to what power is 16? How many 2's do you need in order to multiply them together to make 16? That would be 4. 2 times 2 times 2 times 2 is 16. So your answer is 4. 5 to the 3rd power, 5 times 5 times 5 is 125. 4 to the negative 2 power. Remember, negative exponents move things to the bottom of a fraction. So the first thing we're going to do is do 1 over 4 squared. Negative exponents make fractions. And then you can evaluate 4 squared to get 16. 4 times 4. 7 to what power gives you 343? So use your calculator and start typing in 7s. Maybe you type in 2 of them. Then you type in 3 of them. It is going to be 3 7s. So 7 to the 3rd power is 343. And the last one, notice you have another negative exponent there. So we'll start by moving it to the denominator and creating a fraction. And then you can multiply 6 times 6 times 6 to get 216. Final answer, 1 over 216. The next thing we're going to talk about is this property of equality. So if b is a positive number other than 1, then b of x equals b of y. B to the x equals b to the y. If and only if x equals y. Pretty much what they're saying here is if the bases are the same, the exponents also have to be the same. Notice if this is a 2 and that's a 2, then this x and that 8 have to be equal. So we'll use that as we solve example A. 2 to the 4x equals 2 to the 32. If the bases are the same, we can cancel them out. Then you write what the exponents are next to each other, and you solve. If ever in this video I'm moving a little bit too quickly, feel free to pause between the questions and try them, or even just pause and slow down a little bit. All right, part B. The 3's here are going to cancel. And we bring down the exponents, and we set them equal to each other. From here, you'll solve the equation. I'm going to subtract 2x from both sides, getting me 2x minus 5 equals 11. Then I'll add 5 to both sides to get 2x equals 16. And then I'll divide both sides by 2 to get a final answer of x equals 8. All right, so for this last one, part C here, notice we have that fraction. We want to make that into a negative exponent. We want to make that into a negative exponent. So we're going to write the 4 to the x power right here, and then we're going to bring down this 1 over 4 to the 4, but we're going to write it as 4 to the negative 4. So just like we did up here, right, with this problem here, it was a negative, you made it a fraction. Now it's a fraction, and we're going to make it a negative. Once you have that, you can cancel the 4's, and x will be equal to negative 4. For the next set of examples, notice that these numbers don't immediately cancel out. So what we're going to have to do is do just a little bit of math to figure out how we can get our numbers to cancel. So we want to get these to be the same base. So we want this 3 and that 81 to be the same number. So when I think of 3 and 81, I think of the number 3. I'll use the number 3 as my base. Because the left side is already a 3, I will just bring down my exponent. And then I have to think 3 to what power gives me 81? 3 to what exponent gives me 81? So you use your calculator and start just multiplying out 3's. After I use my calculator, I got 3 to the 4th power is 81. So I'll write the 4 right there. That 3 to the 4th is taking the place of the 81. Now that the 3's are the same, I can cancel them out. And then you would solve the equation. Subtract 1. And divide by 2. X equals 3 over 2. You could also write that as a decimal if you'd like. All right, for part B, 4 and 8. The thing about 4 and 8 is 8 cannot be written as a base of 4. So a lot of people look at 4 and 8 and they think about the number 4. However, 4 to what power is 8? Well, I know 4 to the first is 4, and 4 to the second, 4 squared is 16, and notice how it skips right over the 8. So that means I'm not going to be able to use 4 as my base number. I'm going to have to use an even smaller number. We're going to have to use 2 for this problem. So I'm going to make both of these sides a 2. And then 2 to what exponent is 4? 2 squared would be 4. So I'm going to write 4 as 2 squared. So this 4 became this 2 squared. Now the 2x next to that needs to come down into a parenthesis. So this 2x goes right there. All right, let's figure out the other side. 2 to what power is 8? How many 2's need to be multiplied together to make 8? That would be 3. So 2 to the third is 8. And then again, anything left, any exponents that were already there, we just got to bring them down into a parenthesis. All right, that's a challenging part. The rest of it, just your regular solving. 2 times 2x, I'm going to multiply those to get me 4x. And over here, 3 times x minus 1, I'm going to distribute 3x minus 3. And then we'll subtract 3x from both sides. And 4 minus 3 is 1x. I'll just write that as x equals negative 3, and my problem is solved. For part C, I have 3 and 1 over 27. I think I'm going to use my base as a 3. So I'll bring this down as a 3 and bring this down as a 3. And remember this 1 over, remember that fraction, how we get that exponent. If you look back at this top example here, make into a negative exponent. So we'll make those fractions into negative exponents. So 3 to what power is 27? And then make that answer negative. I know 3 to the third is 27, so 3 to the negative 3 would be 1 over 27. And on the left-hand side, that's already a 3, so I don't have to do anything to change that side at all. See if you can cancel the 3's and then solve the equation. All right, so when you solve the equation, the final answer should be x equals 1. We have a few more problems to do on the backside, just extra practice with getting these common numbers. So now would be a good time to pause the video and see if you can do these 3 problems. That'll help you decide whether you understand it or not, or whether you need to go through these with me. For part D, we're going to have a common base number of 3. So you're always looking for a pretty small number for the bases. The left side is already a 3, so I'll just copy it down exactly as I see it. The right side, the 9, can be represented as 3 squared. So in your head, you're thinking 3 to what exponent gets me 9? And then you can rewrite 9 as 3 squared. Remember, you already have an exponent next to it, 2x minus 1, so we'll bring that down. From here, you can cancel your 3's, your same base, and bring down your exponents next to each other. On the right-hand side, this is a distributing problem. That would get you 4x minus 2. And then we can subtract 4x from both sides. 5x minus 4x is 1x. I'll just write x. And then I can bring down the minus 2. X equals negative 2. Right, part E. 4 and 256. 256 is a larger number, so you're probably going to need to use your calculator here. And I'm going to start to see if I can use 4 as a common base. So can I multiply 4's together until I get 256? So start typing your calculator, 4 times 4, and then 4 times 4 times 4, and then 4 times 4 times 4 times 4. So 4 to what power is 256? I'm getting 256 when I get 4 to the 4th power. So I'll write 256 as 4 to the 4th power. And then this is already a 4, so I can bring this down as 9n minus 2. And notice they changed it from an x to an n. They just changed the variable. That is not going to affect how we do the problem at all. The 4's cancel. Bring down 9n minus 2 equals 4. Add 2 to both sides. 9n equals 6. And divide both sides by 9 to get the letter, the variable, by itself. N equals 6/9. However, that's a fraction that you can reduce. So you want to make sure you do that. Both of those can be divided by 3. So divide the top one by 3. And divide the bottom by 3. Get an answer of n equals 2/3. Right, and our very last problem, F. I've got 8 and 16. So 8's not going to work as a common base because 8 squared is not 16. 4 is not going to work as a common base because I can't get 4 to make 8. 4 squared is 16, not 8. So I'm going to have to go all the way down to 2 as my common base. So 2 and 2. 2 to what exponent is 8? In other words, how many 2's do you have to multiply together to get 8? 2 to the 3rd is 8. Bring down the exponent that's already there. On the other side, the negative is what's going to create that fraction there. So I know I need a negative number. And then how many 2's together make 16? 2 to what exponent is 16? 2 to the 4th. So over here on the right side, I have 2 to the negative 4 power, and that's what helped create that fraction. Now we can cancel out our 2's. And right here with this 3, we'll distribute. 3x minus 6. And then I can bring down the negative 4. Add 6 to both sides, trying to get the x by itself on that side. And divide both sides by 3. And we get another answer of x equals 2/3. There we go.